Hey everybody, happy Wednesday. Sorry I missed you earlier. I took some cold medicine that my wife said was really good, and it was really good, but it just knocked me out for a couple hours, and I just slept. So I'm feeling a little better, but I ended up picking up a case of COVID out in Pennsylvania while we were there. So my oldest daughter's still there because they won't let us into the hospital until we finish quarantining. So we're we're working our way through that here at home, and it's miserable. But it could be worse. So it's just cold symptoms and just the general fatigue and things. So, but a couple things we've got on tap for today. Um, this chapter 15, it's actually relatively short, polymorphism and virtual functions. We touched briefly on it way back at the end of October when we talked about chapter 11. So we'll bring up some of those ideas again and then look at this new idea of an abstract method or abstract class, which is really cool. There's a lot of things you can do. They're really powerful. So we'll get to that. And then later on, I'll do another video for you guys, some tips and tricks that you might be needing for the final project as we try and write out these whole big lists or vectors to disks using binary files. So it sounds a little crazy with the final project. I haven't got a lot of questions yet. I think that means people haven't really started, but I'll give you some tips and tricks for that, and then we can keep moving on. And then this exceptions and templates should be relatively short. Again, I'm excited to get to exceptions, which is the right way to deal with problems in object-oriented programming. And then we'll look at writing your own templates and how we can use those. It's a pretty advanced feature, but the standard template library has most of the things that we're going to need. And we'll get to that last week as well. So we're moving right along. I appreciate you guys hanging in there. I know it's been kind of a rough semester, so keep in touch. Let me know if there's anything I can do for you. And if not, we'll jump into this idea of polymorphism. So way back in chapter 11, I was just pulling this up here, we did this inheritance thing where we said, okay, let me zoom this in, sorry. Whoa, that's okay. Where student is a type of person. Remember, inheritance creates an is-a relationship. This is-a, whether or not you call it a subclass, a child class, or derived class. Right, so student is the subclass, the child class, the derived class of the superclass person. So it does all the things person does, and then we specialize it. So what polymorphism lets us do is this really cool thing. Oh, this is actually zoomed a little too much. Not more, less. Where we said, okay, I'm going to make a person pointer that points to my student address. So because a student is a person, I can create a pointer of type person and reference a student. And C++ is okay with that. And then what's cool is if we have a virtual method, so virtual is the keyword that we use to say, hey, I want to be able to override this, I can get the correct version here, even though it thinks that this is a person pointer, it at runtime will go and find the correct version here of, what do we call this, get ID number, because we marked it as virtual. If you don't mark it as virtual, polymorphism doesn't work. But if you mark it as virtual, then you can go and override it here. And where do we do that? Here we go, get ID number. And we did like 1,000 plus here for this version. So it'll get the person's ID number, and then it's going to add 1,000, because that's just a silly thing we did with student. But treating the child type and treating it as the parent type, right? Saying, hey, it's a pointer to the new item here. So let's add a new header file here. We'll call this. See, they had some good ones here. So they went like class animal, I think. Right, and then we have our private section and our public section. So if animal does a couple things, right? You might have an int number of legs or something, number of legs. And then maybe has a constructor. So this is animal that takes an int number of legs. And I don't know, maybe a string for name. Sure. String for name, and maybe a string for type. Is that what we need? Include string. String Base standard. Okay. We have a string for name. And then our constructor then will go set those my number of legs to the number of legs, and then I can take my name equals this name. Name. Oops, missing that little arrow there. There we go. Nope. And I'm losing my shortcut keys. Edit, advanced, not format. ED, Control E, Control D. There we go. For format. I'll take care of all those lingering spaces and stuff. Sure. So that's animal, and then maybe animal does a funny thing where it returns a string for, I don't know, make noise. And if it's just a regular animal, we'll say, I don't really know, animal noise here, because we don't really know, right? It's sure some sort of animal noise, and then maybe we want to extend animal, and let's mark this virtual because we want this to be extended. So we're going to write a class for sheep, maybe that is a public animal, and animal, right? And then, because we have a constructor, remember we're going to need to call my parent class constructor. If we had a no argument constructor, that could happen automatically. But because we have parameters here, we need to call this one directly. So sheep, then, we know what the name is, and we know how many numbers of legs it has. So we write our private public section here. So when we write our constructor for sheep, right, we don't need any arguments, and we just call the animal constructor. Oops. Animal, and we can give it 4 legs and sheep. Right, and that's what our constructor does. And then this one's really just like empty. We don't really have to do anything else. I don't know, or maybe sheep has a color. Sure, why not have a string for color? So maybe we do want a string for color, and then we can set our color to that color. I like that, because sometimes you have black sheep, sometimes you have white sheep. Its color is the color you gave me. Okay, and semicolon there, and then we want to make noise. So we want a string make noise. That should probably be a lowercase o up there. And in this case, we're going to return right, something like that. KD, ED. There we go. ED format. So sure, we can make a noise. So we're inheriting from animal. We do all the things animal does. We'll have to call our parent class constructor, and we can have our own color. Sure, we can make noise. I like it. And okay, maybe we have a get name too. String get name, return name, and some curly braces. There we go. Okay, so we can get our name out. Right, so then what I can do is I can make pointers to these things. So I can have an animal pointer of type my sheep or something, or let's call it my sheep equals a new sheep. And then we'll tell them this one is a black sheep. Black sheep. We need to include our header H file. There we go. So it's a pointer of type animal. So the only things I can do with my sheep are get name and make noise. Yeah, so if we added in another method here, I don't know, what does sheep do? Sheep will eat grass. Sure. So I'm not going to see that eat grass method here on my sheep because it's a type of animal pointer. So you only have access to the parent class methods. But if I do the make noise, because we've marked it as virtual, right, using this virtual keyword here, at runtime, it's going to dynamically find which version it should run. And that should probably see out that thing, right? See out. And an endl to be pretty. Okay, so we run this. We should get black sheep. So at runtime, it's dynamically binding to the make noise function of the correct type. And that's all because of this virtual keyword. If we take out the virtual keyword here, it's not gonna work. It's gonna say, oh, it's an animal pointer, sure, run the animal version. animal noise here. Right? So you need to mark it as virtual. Then we need to override it. Okay, so that is letting me treat this polymorphically. That's our keyword here, this polymorphic behavior here. So we can even add some notes, right? Because the function is virtual in animal, and run the subclass version. Okay. All right, cool. Other cool things you can do here. So this is sort of silly to say, hey, return animal noise here, because we don't really know what it does. Right? So what you can do is you can make this what is called a pure virtual function, which is really cool. So we say, hey, this thing equals 0. It seems really funny, but that's the syntax for a pure virtual function. What that means is we're not going to define it at the parent class level, and we're going to force you to define it as the child class. So what happens if we Control-E, Control-C to comment that out? If we try and run this now, it's upset because it says, oh, object of abstract class type sheep is not allowed. Pure virtual function, animal, make noise, has no override. Now, it's funny it doesn't give us the error over here, but because we're extending animal, and this is marked as a pure virtual function, you can't create an instance of sheep without that definition. You can't create an animal either. So if I said like animal equals a new animal, animal pointer equals a new animal, and we were to say, I don't know what, 4 legs and dog. Right, we're going to get that same error. It says, oh, abstract class type animal is not allowed because make noise is a pure virtual function. So if you mark something as a pure virtual function, you can't create an instance of that class. That class is no longer able to be created because it doesn't have a definition. C++ knows that it's purely virtual. It exists so that when we do override it, or when we do inherit from animal, we're forced to override it. So it makes it so you can't have that crappy default that said, oh, some animal noise here. So if you know that there's going to be some definition in your subclasses, but you don't have a appropriate default definition, you can make it purely virtual here. Okay, so we're going to forget animal, and then we're going to go back to sheep, and then we'll uncomment this one out here. EU, I think, yeah, there we go. Control-E, Control-U. Now I can make a sheep here because I've overridden that pure virtual function. So this is equals 0. Setting it equals 0 as a pure virtual function. Can't create an instance of this class anymore. Okay, so you can do a lot of cool things with this, right? If we know that like a generic animal has a bunch of properties, great, we set that up as the base class, and then our specialty classes down below can override it, right, with whatever they need to do, their special instances. But it guarantees that they will be forced to set a make noise rather than optionally override it. That's kind of the big difference there. Okay, let's see some other things. Virtual functions, yep. Virtual, good. Bindings, yep. Other things you can do, right? This virtual, it forces us, or it allows polymorphic behavior if we had a default here. If you don't want someone to override it, like just not even allow them to, you can add a final keyword to the function definition. So I can say, oh, this is the get name final. No, I think I put it in the wrong place. You can use the final key. Where does it go? I don't know. That was not helping. C++ final method. Yeah. Final. Oh, because it's not virtual. What? All right, I'm confused by that. I'm sorry. That's all right. All these are bad. That's okay. But it'll let us do that so that you can't override it. And there are some things that you might not want people to change for that behavior. Um, so you can go about marking it that way. Another idea with these pure virtual functions is you don't, you can make something that is only virtual functions. And at that point, it's essentially what we call an interface, a pure virtual class at that point. So if the class is entirely virtual functions, it's essentially like an interface. The idea is that we're saying it will have these methods, and it's up to you to implement it. And when we get into the standard template library, that'll make a little bit more sense because we're going to have different methods of implementing these same type of functions. So you can do some cool stuff with it. As saying, hey, this is a purely virtual class. It has no definitions at all, and we're going to let you fill it in any way that you want to. All right, so I think that covers most of what we need here out of chapter 15. I'll come back with another video later for some tips and tricks for that final project, working with binary files and vectors. It's not going to be so bad, but it's a little silly because we're going to create an oversized vector that can hold way more than we're going to need, and we write the entire thing to the file, and then we read it back when we go. All right, if you have any questions, let me know. You guys take care.